Now Titan can not only be viewed through the cameras of interplanetary vehicles, but also listened to. There is a story that a microphone lowered into the Kola ultra-deep borehole recorded the sounds made by representatives of an underground civilization, who were greatly frightened by the drill. But this is, of course, fiction. Finish, in fact. There was no microphone, no sounds. Methane with sulfur compounds just quietly flowed out of the well. They knew then that if the Russians drilled, a bomb could come after the drill, for purely peaceful purposes, but atomic, maybe even a spectral bomb. So, the strangest place, where the microphone was able to stick, at the moment is the surface of Titan, the largest of the satellites of Saturn. On the descent vehicle, Huygens, as well as on the landed Venus, had an external microphone. There were also cameras, but the beautiful picture, Huygens, did not see because of the low transparency of the atmosphere of this body, combined with the same low level of illumination. But here, sounds, through the darkness and gloom, almost impervious to the dim rays of the distant sun, through the torn wisps of brown haze, creeping. A dreary, piercing howl drifted over Titan. In short, the sound of the wind was recorded by Huygens. That makes sense. If Titan has an atmosphere, a very dense nitrogen atmosphere, why shouldn't there be wind? But there is, however, an interesting question. Where did the atmosphere itself come from? Jupiter's satellite Ganymede is bigger. Nevertheless, neither it nor Callisto, comparable to Titan in mass, has an atmosphere worth mentioning. Mercury has no atmosphere and, in fact, not even Mars. How is it that Mars is small enough to hold a gas envelope, while the order of magnitude lighter Titan is large enough? First of all, it is worth noting that although Titan is now the only moon in the solar system with a dense atmosphere, in the not-too-distant comparatively past, 1 billion years ago, it was accompanied by Neptune's satellite Triton. Even at the present moment, Triton's nitrogen atmosphere has not disappeared, but only frozen for the most part. Thus, there are two exceptions to the rule. The rule is that planetary satellites do not have primary atmospheres. Primary is still made up of gases that were part of the protosolar nebula. Moons are born in the orbits of planets that have entered the final stage of formation, the catastrophic stage. When the dust and gas of the protoplanetary ring have already been collected in planetesimals, planetesimals stick together into planetoids. The ring has turned into a necklace of large bodies, and they merge with each other already. Mergers at this stage are impactors of monstrous force. The planet orbits like a boiling, exploding cloud of red-hot vapor surrounded by millions of tumbling debris. When the bombardment stops, not completely, but at least in general terms, the haphazard cloud of material ejected in the collisions is compressed into a disk across the planet's axis of rotation. Silicon and metal vapor condenses, turning to dust. Water vapor freezes, forming snow. But that's if the temperature permits. 4.5 billion years ago, water froze only in the orbit of Jupiter. Gases, on the other hand, dissipate, or blown away by the solar wind. When the debris disk, in turn, disintegrates into rings, now protolunar, there are few volatile, at a given temperature, substances in it. Then, when the moon experiences differentiation of the interior, additionally heated by tidal friction, entering into gravitational entrapment with the planet, intensive volcanism, in the case of icy moons of distant planets, cryovolcanism, will still lead to the release of significant amounts of gas, and even to the formation of a not-too-dense atmosphere, which will be quickly lost due to the low gravity of the body. But if everything is so simple, then why, after all, one of the moons has an atmosphere 5 times denser than the Earth's, and another one had a serious atmosphere in the relatively distant past? We can start with Triton. Lunar laws are not written for it, because it is a satellite of the planet only by position, but not by origin. Triton is a planetoid of the 10th belt, the older brother of Pluto, captured by Neptune during the period of stabilization of planetary orbits. That is, it was formed not from debris ejected from the planet, but from the substance of planetesimals. A lot of frozen gases, when absorbed, of course, vaporized and volatilized, but much remained. And the vapor that escaped in the process of impactions still remained in the protoplanetary ring, condensed and absorbed by planetoids. And Titan? Titan isn't a real moon either. When a planet forms, there is a small but real chance that the planetoid will not be absorbed but will nestle in a stable orbit near the main body. Given that Titan is 2 orders of magnitude heavier than all of Saturn's native moons combined, the other satellites had to squeeze in. It was probably Titan's capture that led to the collapse of several large bodies in the Roche sphere and the formation of Saturn's famous rings. Titan was formed in a ring that was already cold enough, but still rich in gases pushed there from the inner regions of the solar system. So, this planetoid managed to collect a lot of methane and ammonia, later turned into nitrogen. Its gas envelope was once denser than Venus's. Titan's current atmosphere is only 1/20th of the original atmosphere. Here lies the answer as to why this relatively light body did not lose its atmosphere. It didn't have time. Initially, there were too many gases. The low temperature also played a role, making it difficult for molecules to reach cosmic velocity. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel. See you soon.